Okay, guys, so for this video, this is all about systems and solving systems. And remember, you need to know what a system is, first of all, and a system is exactly this. It's two or more equations. That's what a system means. So if you're wondering when they use that term system, it means two or more equations. That's important because a system means that you are going to be talking about two equations and you're going to be looking for a solution to both equations. If it is a solution to the system, it has to be true for both equations. So in these, all you're doing is checking to see if this point is a solution to both of these. Now, what I do personally is I start with the easiest equation. I think number 2 looks like the easiest one. This one right here. I pick the easiest one to plug in, and if it is a solution, this point is a solution, then I check the second one. If it's not, then I move on. Okay, so let's do this. The simplest way to do it, excuse me, is to write, actually, let me do this, is to write the equation as it was given and then substitute in. So y is equal to 7 times 0 minus 4, and I forgot to substitute in for the y, so let me go back and do that. Hello, we don't want to do that. Let's do Control-Z that. Hey, well, I got rid of it anyway. How's that? Okay, we need to substitute in for the y and for the x. Okay, so look, I get 4 equals 4. So yes, it's a solution to that. So now I need to check it in the next equation. So 14x plus 2y equals negative 8. Let me check 0, 4 for that one. So I'm going to plug negative 14 times 0 plus 2 times 4. And do I get negative 8? And the answer is no, I don't. I get 8, which does not equal negative 8. So it's not a solution to both, and therefore it's not a solution. Okay, I don't think I could do it because I wrote it here and it was, I got to be careful with the erasing, but a lot of times what I'd like to do is just erase these pieces, but I'm just going to write it below. So then you just go in and you just substitute again, okay, to this one. Okay, so we're going to go check the second point. 5 is equal to 7 times negative 2 minus 4. 5 is equal to, and you probably can tell right now it's not going to equal, so we don't even have to go further. Done. Okay, next, let's check another one. Let's check 317. So y is equal to, actually, let me not do y. Let me not do y. Let me do this. Let me not do y. Let me do this. Let me see if I can pull that back over. Learning how to do this, pulling this stupid thing over. Okay. No, I did not want to do that, sir. I swear, this thing is driving me crazy. It only does this when I'm recording. So I'm not sure if it's a recording issue. Anyway, we'll get this. Okay. You know what? Whatever. It takes me longer to try to erase it than it does to just plug it in. All right, so let's plug in. 17 is equal to 7 times 3 minus 4. And you can see 17 is equal to 21 minus 4. And that is true. Yay, good. So now we need to check it in the second equation. Okay, is it true for the second equation? Negative 14 times 3 plus 2 times 17, is that equal to negative 8? Equal to negative 8. Let's check it. Okay, I think I'll shrink this down just a little, you guys, so I have a little more room. Okay, 14 times 3. That's 14 times 3. I swear I'm going insane. I didn't do this. It only acts like this. I swear I try to do this when I'm not recording and it doesn't do anything like this. Okay, 12. I think that's 20. Wait, 14 plus 14 is 28. That's 12. 42. Negative 42 minus 34 plus 34. Is that equal to a negative 8? 42, get down to 34, that's 6 and 2. Yeah, it is. Yay! So now we have a solution. Let me see if I can actually move it. Can I make it move? See, now I can't even make it get to that stupid thing. I don't know how I do it. It's like a pain in the butt. Okay, so this actually is a solution. So you get the idea. You just plug and play. The next one, let's see, negative 11, that works for the first one. Second one, positive 14, minus 22. Yeah, I think that one's going to work as well. You can check it out, but I think it does work. But you get the idea, okay? Just plug and play, see if it works, check it. All right, so this one you're going to crack up at me, okay? This one's to know whether or not the system is, so excuse me, and they give you these words, okay? Oh God, I am just like, I don't do anything. Swear, this is driving me nuts. It's just doing this while I record. You could give me $100 to try to make it do this, and I couldn't do it. Okay, so they've given you 2 lines, and then they've graphed these 2 lines, and then they're asking you whether the system is consistent independent, consistent dependent, or inconsistent. I want you to know that I'm not going to test you on this because I can never remember it myself. That's why I think it's funny. I would like you to look at the explanation in ALEKS, and it will tell you. I'm pretty sure this one is inconsistent. It makes sense to me because look, there's no solution. Okay, it has no solution. I do not know whether the same lines, when they're the same lines, I would think that it would be consistent and consistent dependent. I do know it has infinitely many solutions because basically it's the same line. You see what they did? They graphed this line and then they graphed the second line, and it's the same line. If you guys were to solve for y on the second line, you would get negative 5x minus 4, and then you divide by 2, and you would get y is equal to negative 5/2 x minus 2. It's the same exact line. Okay, so you can look at that up. I don't know what it is. You can look at that up. That's what I said. I can speak English. You can look that up. All right, this one has one solution, and these are the ones we're mostly going to be working with. It's a unique solution, and you can pull it out. It is negative 2, 0. I'll write it next to it because there's too many. Oh, wait, 0, negative 2. Let's try the x first, okay, Miss Baca? Okay. Okay, it's 0, negative 2. All right, I don't know. I'm going to guess this is consistent independent, and this is consistent dependent. You can tell me if I'm right. Just look it up. It's that simple. Just look it up, take a picture, fill it in for that, and I'll never test you on it again. I just want you to see it because it does pop up here and there. So it kind of is important, but I don't know. I never see anybody use this. All right, next. Okay, so you guys are going to have to learn how to solve systems 3 ways. One is graphing, okay, and that's where you graph the 2 lines and look to see where they intersect. The intersection is the solution, okay? The second way is graphing by elimination. I mean, not graphing, solving by elimination. And the third way is solving by substitution. So I'm going to go through all of these, and we're going to do a couple of special cases. But I don't want you to forget how to graph a line. You can always use a table, you guys. I'm going to get this purple. Look, I loaded up this pretty purple. Ooh. Okay. The only thing you need to do is graph the lines, find the intersection. Okay, now I can't guarantee that they're always gonna intersect. They will give you sometimes those with no solution or infinitely many. Sometimes they are going to give you parallel lines, and the answer for parallel lines is no solution. These aren't parallel. Work with me here. Use your imagination. Or if they figure out how this works, I can't shrink it even if I try, you guys. It's so weird. It's possessed. My program is possessed. Okay. They also are going to give you where you graph 2 lines. You graph the first line, and then the second line will graph right on top of it because they're the same line. And that's the case of infinitely many. But really, I'm more interested today in talking about these, where you have two lines and they intersect at one point. So the only task you have right now is to graph these lines. You can use y equals mx plus b if you are, you remember it, okay? I'm not going to teach it. I'm going to teach a table. Because you know what? If you can remember that there's a table and you can create a table for any equation, you will be home free no matter what. There's no tricks. There are no tricks whatsoever. So I'm going to do the second one first, okay? Y equals 1/2 x minus 1. So you just pick points. -1, 0, 1 are my personal favorite. And then you plug them in. Y is equal to 1/2 times -1 minus 1. Now here's a cool little trick. See how I'm going to get a fraction with this? And that kind of sucks. So instead of putting -1, I'm going to change it so that it is a multiple of the denominator. It's one of the best tricks out there. If you have a fraction and you're going to multiply it by the x, pick the x so that it cancels out the fraction. So now check it out. If I do 2 here, that's 1/2 of -2, which is going to be -1 minus 1, -2. So -2, 2, -2, -2. Boom. First dot, first point. Now plug in a 0. 1/2 times 0 is 0, minus 1, minus 1. 0, -1. You guys, I might be working these too fast. Like you might need to take a little more time, and that's perfectly fine. So y is equal to 1/2 times 2 minus 1. Cancel, you get 1, 0. So you get 2, 0 over here. 2, 0. Okay, and then you are simply going to connect the dots. Don't erase the dots. Apparently, I did that. Let's try not doing that. There. I moved that. Wasn't that amazing? Look at me. I moved dots. Who knew? Okay. Let me try doing this again. Okay. Connect the dots, and then you have a line. All right. I'm going to pick a different color for the second line. Pick red. Okay. And now you have a choice. Okay. We're going to do a table again. Okay. And we are going to do x. Okay, good. I'll pull it back over here. Okay, x and y. Okay, I'm going to take a line tool. We're going to pick 3 points. All right. Now you can leave it the way it is and just figure out some points, or you can solve for y, which makes it a lot easier, in my opinion. If I solve for y, I get 2x minus 4. Like all I did was move the 2x. I added 2x to both sides. So now I substitute in. I'm going to pick -1, 0, 1. Those are my go-tos. Y equals 2 times -1 minus 4. Y equals -6. If I plug in a 0, I'm going to get -4. And if I plug in a 1, I'm going to get -2. Okay, you can plug in now. We'll go over here. And it's going to be, let me back. Back. Okay. Okay. I'm going to go -1, -6, -1, -6. I don't know why it keeps wanting to go over there. I need my points, man. Stop doing this. I hope you guys are highly entertained by the fact that I am struggling with this. If it does nothing else, I hope it entertains you just a tiny bit. Okay, 0, -4, and 1, -2. 1, -2. All right, and then we're going to go and we're going to make a line. So I'm going to put my line tool on and go through here, here, and look, you can see where it goes through. The point is 2. Okay, the point is 2, 0. Now, when I plug that back in, it should be a solution to both of them. I can already see that it was. I actually graphed it in that one, If I wanted to check this line, I could plug in a 2. And I would go, okay, 2 times 2, 4, 4 minus 4, 0. So you can see that is a solution to both equations. And that's it. Graph them, look for the intersection. That's all there is to it. Now, the next thing you're going to have to learn how to use is substitution. So this is the easiest case. When they actually bring it to you or give it to you solved for one variable, that's what you want. You want to have one variable solved for. So you can see that y is 3x plus 13. Okay, well, what we're going to do is we're going to take that, see, y, lock it down. Oh, I didn't lock everything down. Are you kidding me? That's dangerous. Hang on, lock. Okay, all right. So do you see where this y is? What we're going to do is we are going to replace this y with this value, this 3x plus 13. So you write 4x plus 3y equals negative 13. And now we're going to substitute in, hence the name substitution. So 4x plus 3, and now we're going to substitute in that value. 3x plus 13 equals negative 13. I didn't line up my equal sign because I didn't anticipate the space well. I'll be nicer on the rest of the problem. 9x plus 39 equals negative 13. So look what we accomplished by substituting it. When we substituted in, the whole point was to get rid of one of the variables. Check it out. Now I have one equation, one variable, and I can solve it. I cannot solve one equation with two variables. Okay, 13x, let me just keep going, plus 39 equals negative 13. Okay, we're going to subtract 39 from both sides. Draw a line if you decide to show your work. 12, carry the 1, negative 52, 13x, x is equal to negative 4. All right, 13 goes into 52 4 times if you didn't know. You do know because you guys play cards, right? And there's 52 cards in a deck and each suit has 13. All right, so now you find x. Okay, what you have to do then is plug it back in. And the easiest way or place to plug it back in is the one that's already solved for y. Y is already solved for. It says y is equal to 3x plus 13. So all you need to do is substitute it in. 3 times negative 4 plus 13, y equals negative 12 plus 13, y equals 1. And then your point of intersection is negative 4, 1. You need to put it as a point, and you put it, that is the solution. Okay, actually, they put it, patience, Ms. Baca, patience. This will teach you patience. This will teach you lots of patience. Okay. No, my dear. Okay, there we go. Sorry about that. Hopefully, again, like I said, hopefully you're just entertained. How much struggles will Ms. Baca have during this video? So, okay, that is substitution. I did not give you a ton of problems of substitution. I didn't even give another problem. So a lot of times what will happen is they'll give you something like this. 2x minus y equals 4, and maybe 3x plus 2y equals 8. And you can see that this y is kind of by itself. Like, I mean, at least it has a coefficient of negative 1. It's close. So what you have to do is sometimes you have to solve one of them for a variable. So I would go negative y equals negative 2x plus 4. And then I'd have to divide everything by negative 1. And then I would get y is equal to 2x minus 4. And then I'm solved. And then I would plug it back in. Okay? So this isn't part of this problem. I just wanted you to be prepared for if they don't give it to you in y equals mx plus b form and instead give it to you in standard form. You have to solve for the variable. And sometimes x will be easier to solve. All right, next. Okay, I kind of am anticipating that you guys have done this before and you kind of know. Um, all right, this is with elimination. Okay, it says with addition. I'm going to tell you, I always want you to use addition. Always, always, always. So, what I want you to do is take a look. I'm not doing anything. It's possessed. I'm telling you. Touching anything. I'm not doing anything. All right. So, look at these two equations. Okay, you could solve for y and plug in, but this is not what we're doing. Okay, we have to use elimination. I wonder if it's just taxing my computer because I have too many things open. Hold on a minute. Let me see if I shut things down, if it helps it. It did yesterday. Okay, so all of these are there. I'm going to shut down all of my windows and see if that helps. Okay, here we go. Hopefully that does. All right, so the goal of elimination is what we're going to do is we're going to use a really cool trick. We are going to add these two equations together and we are going to eliminate one of the variables. As you can see, y would be really easy to eliminate. The only thing you need to do is we have to change this so that when we add them, it cancels. We want to create a situation where we have opposites. For example, something like 3x plus 3x minus 3x, and they cancel. Or say 8x minus 8x, so that when we add them together, they cancel. Okay, and in this case, we have y and y, but if we add them together, we're going to get 2y. So instead, we need to multiply this equation by a -1. This is one way to show your work. Another way to show your work is literally just draw arrows to the side, and then you can put like times -1 or whatever. I typically do it this way. Plus y equals 14. And then we're going to go -8x minus y equals +14. And then you'll see, look at what we created. We created a situation that when we add the two equations together, this is going to cancel. And we're going to get -14x equals 28. And therefore x is equal to -2. So we solve for x. Now you have a choice. To find y, you have to just plug it back into one of the equations. Does it matter which one? No, who cares? Pick one that looks nicer. I always pick the one that doesn't have negatives. Those are my favorite, personal favorites. So I'm going to go to pink. I'm going to go 8x plus y equals -14. And we're going to go 8 times -2 plus y equals -14. We're going to -16 plus y equals -14. Add 16 to both sides, and we're going to get y is equal to 2. And now we've solved it. Okay, and your point is -2, 2. And if you plug it back in, you should be able to check and see that it's correct. Since I used the second equation, I'm going to plug it back into the first equation to check it. Does it equal 14? Look, 6 plus 2, 6 times 2, negative times negative. 6 times 2 is a positive 12, plus 2 is indeed 14. Check. Sorry, 14. Check. So it checks. Okay, so the whole point here is to get a situation where you cancel. And I think you'll get experience with this one, at least even with me, because I'm going to do more problems. Okay. This one is a little more complex. Take a look at it. There is nothing that we can add together. So we have to choose a variable because it says with elimination. By the way, these are way more easy to do with elimination than substitution because when you solve for y, you're going to get fractions. It's a kind of a pain in the butt. All right, so I'm going to pick x. I'm going to pick x to eliminate just because 3 times 4 is 12, 4 times 3 is 12. For some reason, for me, that's easier than trying to do 36 with 9. In other words, I'm trying to get these to the same number. So you're kind of looking for the least common denominator, whether you realize it or not. It works out that way. So I am going to multiply this one by 4. Okay, you need 2 sets of parentheses, you guys. can't put parentheses around the equal sign. And this one I'm going to multiply by 3. Okay, so here we go. You get 12x plus 16y. By the way, you guys, when I give notes, I'm giving them pretty fast. So if you ever need to stop and think, or think like, okay, wait a minute, maybe I need to think about this before she goes on, do that, please. Do not let me just keep talking too fast. 42. All right. Look what I created. I created a situation where 12 and negative 12 are going to cancel. Okay. And I magically moved my board again, but I don't care because I'm here. Okay. 27 minus 16. Make sure you subtract from the, largest from the, the smallest from the largest. Negative 11y is equal to, and we're going to get 2, okay, 2, and 2 negative. So y is equal to 2, positive. All right, be careful with your negative signs. Then to solve for x, all we need to do is plug it back in. I'll pick a different color to solve for x. So I'm going to pick the first equation because it doesn't have any negative signs on the left-hand side. So I go 3x plus 4 times 2 equals negative 16. 3x plus 8 equals negative 16. 3x equals 24. X is equal to, I hope I'm doing this right, negative 24, right, you guys? Minus 8. I shall work when I get confused, or just double check. Okay, yes. And so x is equal to negative 8. So the point is negative 8, 2. Now, how do I know I'm right? I can plug it into the other equation that I didn't use. I didn't use negative 4x minus 9y equals 14. So if I do that, 4 times x minus 9 times y, does that equal 14? 32 minus 18, does that equal 14? Is 18 plus 14 equals to 30? Yeah, it is. Okay, so that equals 14. 14, check. Okay, so we know we did it right. And that's your answer. Next. Okay, so this one has fractions, and there's a trick to getting rid of fractions. Okay, I think we've already learned it, but I'm going to state it again. To get rid of fractions, multiply by the LCD, least common denominator. You guys, it'll get rid of them. So there's a 2 and a 4 here. So to get rid of the denominator, we're going to multiply by 4. It's a lovely little trick. You're going to love it. And in this one, okay, because it has a 2 and a 3, for that one, we are going to multiply by 6 because that's the least common denominator between 2 and a 3. And then watch what happens. You guys, it's lovely, it's amazing, and you get rid of it. So I'm going to draw a squiggly line to separate the fact that I'm working on this. And here I go to red. I'm going to use red to show you. Okay, so we're going to distribute this 4. So we're going to go 4 times 1/2 x plus 4 times 1/4 y equals negative 16. Okay, and then I'm going to go ahead and do the green underneath it. Okay, so the green is going to be 6 times negative 2/3. Keep your levels and you'll be fine. Don't be scared of fractions if you keep your levels. Equals 12. All right, now we're going to go move over here. Okay, I'm going to grab my red. Actually, I'll do my green first. Okay, so 6. No, you could go 6 times 2 is 12. 12 divided by 3 is 4. Or you can go 3 goes into 6. 2 times 2 is negative 4. X. And here, 6 times 1 is 6. Divided by 2 is 3. Or 2 goes into 6 3 times. 3 times 1 is 3. I don't care which way you do it. The cancellation is a little more advanced. Okay? But if you're not understanding it, just keep multiplying numerators and denominators and dividing. So 4 times 1 is 4, divided by 1 times 2 is 2, 2. 4, 2 goes into 4 twice, so you get 2x. 4 goes into 4 once, you get plus 1y equals negative 16. I was like, what, did I forget to multiply? No, I did not. Okay, now you have the situation where we could possibly add these together, but we don't have any that are completely opposite. So I'm now going to multiply this one by 2. And the reason why is I want to cancel the x's. So here we go again. 4x plus 2y. Do not forget, this is the number one mistake. People forget to distribute to that second term. Equals negative 32. And 4x negative plus 3y equals 12. 5y, I'm actually not usually this good, you guys. I should have made a mistake by now. I'm surprised I'm doing so well. Okay, and now I got y equals negative 4. Look, I got my answer. So how do I get x? I just go back and I plug it in. Don't be afraid. I'm going to shrink it down so I can do this. Okay, don't be afraid of fractions, you guys. It's going to be okay. Just keep it on the numerator and you're going to be fine. I'm going to pick the first one because it has less negatives, or at least one less negative. So 1/2 times negative 4 over 1 plus 1/4 y equals negative 4. Now we're solving for y. So I got 2 goes into negative 4 twice. So we got negative 2 plus 1/4 y equals negative 4. Now I could multiply everything by 4 right here. I'm not going to because I'm not afraid of that fraction. Okay, I'm going to add 2 to both sides and I'm going to get negative 2. Now to get rid of this fraction, you're going to multiply by the reciprocal. You guys, that's probably the best advice I could give you to get rid of fractions. Multiply by the reciprocal. This will cancel and look, you get y equals negative 8. Wait, why am I solving for y? I just told you guys I was going to make a mistake, and I literally just made a mistake. I substituted in for x. So, you guys weren't here to tell me, dang it. I needed somebody here. I needed Tori here to tell me. Spaka substituted in for the wrong value. Okay, I'm going to pick a different color so that I could, I don't know, doesn't feel so bad. All right, so I'm going to plug it back into 1/2 x. I'm solving for x. Spaka, you're solving for x. Okay, good. Okay, times negative 4 equals negative 4. I'm plugging it back into the original just in case I screwed up somewhere else. Like, it's a good practice to go back to the original rather than one of the problems that you did. Minus 1, like one of the adaptations, you know, like when you added stuff and you multiplied. So plus 1 plus 1. Draw a line if I show work. 1/2 x equals negative 3. So we're going to multiply by 2 over 1. And we're going to get x is equal to negative 6. Now I have my point. Okay, so it's negative 6, negative 4. And I would show you the check. I don't have room. We could plug it in. It's not that bad, but you know what? I'm actually going to make you do it a worse problem later. So we'll get practice. Okay, so decimals. You can work with decimals if you can work with decimals. Like if you're not scared of them or you don't mind them, but most people hate decimals. So there is a trick. And it is to multiply by the LCD. Now you may not realize that there's an LCD here, but do you guys remember that 0.1 is equal to 1 over 10? 0.01 is equal to 1 over 100. You may not, but that's what it is. All right, so you can see what we want to do is get rid of the decimals. So this one I would need to move it over 1 here, 1 here. So I'd need to multiply this equation by 10. And look, I need to multiply this equation by 10. So that's going to be the trick. Okay, the trick is to multiply it by 10. I'm going to erase those marks I made so that you can see the decimals. Okay, and I'm going to multiply this by 10 and this by 10. Okay, and same thing here, by 10, by 10. And look what happens. Okay, squiggly line to show. I get negative 7x because I move over the decimal one place. 14y equals 70. Don't forget to multiply the right-hand side. 28x minus 6y equals 70. All right, now, okay, what is the easiest one to do? I'm going to say the top one. If I multiply it by 4, I can match up the x's and get rid of them. Okay, so I'm going to go ahead and multiply this by 4. I'm going to change colors. I'm going to multiply this by 4. Okay. And then I'm going to go this way. And I'm going to get negative 28x plus 64y. Nope, that's not right. 4 times 14 is not 64. 4 times 14. 4 times 4 is 16, carry the 1, 56. Equals 70 times 4, which is 280. And then you get 28x minus 6y equals 70. And now we can add them together. And these are going to cancel. And you're going to get 50y equals 350. Divide by 50, and you're going to get 7. Okay, so y equals 7. And all you have to do is plug it back in. And I'm going to choose not to plug it back into the decimal one. I'm going to choose to plug it back into this one, even though I say it's not the best practice. Decimals are a pain in the butt. I'm not excited about using them. So I think I can multiply by 10 and verify it and feel comfortable. So negative 7x plus 14 times 7 equals 70. Like, I'm okay with this equation because I know I multiplied by 10 correctly. That's what I was trying to say, if you didn't understand. So negative 7x plus 28, 98 equals 70. 7x is equal to negative 28 when you subtract the 98. I forgot my negative, bring it down. X is equal to 4. 4, 7, and you can plug it in to check it. Okay, I hope I got it right. Please be right. All right, I think that might be it. Nope, last one. Okay, this is it. Oh, look, I have a graphing thing on the next page. I didn't know I did. Let's try this again. Get back here. Get back here. Okay, hang on. We're going back. There we go. All right. Here's the system. It says they're given. For each system, choose the best description of its solution, and if applicable, give the solution. So you guys, this is actually, they've given you a pretty easy situation here. Basically, all you need to see is if both variables disappear. Okay, I'm going to write this down. If both variables disappear, are you cold? Okay, if both variables disappear, okay, and A, you get a true statement. If both variables disappear and you get a true statement, what that means is that they are the same line, okay? And it means that it's all real numbers. If both variables disappear and you get a false statement, it means you have parallel lines. God, I cannot draw parallel lines today. Let's try again. Oh my God. Okay, I tried, y'all. And the answer is no solution, okay? No solution. Oop, it's my shorthand for solution. So let's do these really quick. And they're giving you kind of easy ones. Check it out. This cancels, and that does not cancel when you add. So you get 0 equals 8. Well, that's not true. So therefore, the system has no solution. Okay, take a look at this one. Let's move the 6 to the other side. You get 2x plus y equals 6. Okay, and then we're going to add it to 2x minus y equals 6. Okay, this cancels, and you get 4x equals 12. X equals 3. So we have a solution. Plug it back in. 2 times 3 minus y. I plugged it into the first one. 6 minus y equals 6. So y is equal to 0. I got that just by logic, you guys. 6 minus something is 6. It has to be 0. So here you would actually put in a point. Okay, you'd put in a point of 3, 0. Now, what happens when you get a true statement? You would get something like this. Let's say you had x plus y equals 4, and then you had negative x minus y equals negative 4. And you added them together. These cancel, and these cancel, and you get 0 equals 0. Well, that is true. That's a square 0. Do you like that? That happened. That was cool. Okay, so that means all real numbers. That's this case, okay? I don't think I have anything else. I haven't. Nope, I'm good. All right, that's this.